Hey guys, welcome to the sixth lesson on advanced C# programming. In this lesson, we're going to take a look at the concept of shallow copies versus deep copies. I'm actually making this video because a viewer requested it, and I agree with him that this is a good topic to look at because it could be quite confusing for beginner programmers and maybe even programmers coming from other languages like C++. The reason why it would be a little confusing for a C++ programmer is because in C++, by default, the assignment operator is a shallow copy. But in C#, the assignment operator is not a shallow copy. It's similar, and if you didn't understand the differences, you would almost always assume that it is performing a shallow copy, but it's slightly different, and we'll hopefully look at why that is. So we're to first start off by looking at the differences between a shallow copy and a deep copy. And I have this little program set up that I'll explain here in a second. But before I need to do that, I need to explain what is a shallow copy and what is a deep copy. Ultimately, they both involve, obviously, copying data from one variable to another, or one object to another. So there are two ways to actually perform a true copy. When someone says that they are performing a shallow copy, basically what that means is that they're going to take all the value type variables of a class, right? And they're just going to copy that data right over. So that the value types, so those are going to be integers, doubles, floats. Data like that is going to be copied over to the class, the target class. That'll just be copied in because it's just value type data. Any data that is reference type, the references will just get copied over. So you could think of the memory locations are just getting directly copied over to the target. So what that means is if you perform a shallow copy and you have reference type data, which we have in this example, that means that both the source and the target, the reference data will point to the same, they'll both point to the same object in memory. So if you modify one of them, the other one will be modified. So a shallow copy just literally will just copy the data over to the target. That's all it's doing. It's not actually doing anything else. So for a reference type, it will just copy the memory location over, so that the target and the source are directly pointing to the same memory location. So if you change one person, the other person will be affected also on reference type data. Value type data is just copying the numbers over. So if you had a 5 in one of them, it will just copy that 5 over to the target, the new thing that we're copying to. That's all a shallow copy does. So we'll look at deep copy here in a second, but let's just go ahead and look at this class. Both of these classes, and just look at what's going on quickly, and then let's look at a shallow copy. So basically, I just made everything public so that we can just access it easy without creating any properties or anything. This is not good practice, making everything public like this, so do not copy it. So I have a public int age, which just is the age of this person, and then I have a public person description called description. And this person description just is their first name and their last name. The reason why I split up like that is just because I want to be able to have a reference type in here so we can see the differences when we perform the copies. So in my constructor for my person, I'm just taking in an age, a first name, and a last name. The age is being directly assigned to my age variable, and the first name and last name are being used in the constructor for my person description that I'm constructing also in this constructor. So I'm allocating this memory right here for my description. So that's all that's going on there. And then for my shallow copy, I have this function that returns a type of object. And the reason why I'm returning type object is because there's a built-in function to the object class called member_clone. And if I highlight it, you can see that it says creates a shallow copy of the current object. So this is a built-in thing that performs a shallow copy for us in C#. And it has a return type of object, so that's why I have this. So all I'm doing is returning this.member_clone. I'm just returning a shallow copy of person. So let's go ahead and see what happens. And the person description class is very basic. It's just a constructor that assigns the data. So let's go ahead and create a person. So person P1 equals new person. So his age, let's say he's 15. His first name is Bob, and his last name is I don't know. Bob Henry. So that's my person I have right there. So the first thing I'm going to do is I'm going to create another person called P2, and I'm going to say that, okay, sorry about that, my dogs were barking. So person P2, I'm going to say person P2 equals, I have to cast this to a person because remember it returns an object, P1 dot shallow copy. So this is going to return a shallow copy of P1, and then I'm going to assign that to P2. So there's a couple things that I want to look at here, but we'll do that here in a second. So after we made the copy, let's just go ahead and print out the age. Just start with that. So console.writeLine P2.age, and this is performing a copy, so we will see that 15 that's coming from P1. So that is a value type variable. So it's just the 15 is just being dumped into P2. If I were to change that in P2, P1 would not be affected. Now, the description, now remember with this, if I go p2.description.firstname, we will see the Bob. The Bob is going to show. But the unique thing about this is that this Bob is pointing directly the same location that the P1 is. So P1 and P2, their person description variables are pointing to the same place in memory right now. So, because of this, if I were to say p2.description.firstname equals Jack. So I'm changing P2's first name. If I were to do that and then display both of them, so p1.description.firstname. So I'm going to display the P2 and P1. We're going to notice that both will say Jack. As you can see, both say Jack. So what's happening there is by performing this shallow copy, it's just copying over the references. So these are pointing to the same area. So because I changed P2's description, P1's description of the first name is now changed also. And that is because we're pointing to the same location. And that's what a shallow copy does. The shallow copy is built to do that. Now, before actually going over the deep copy, I just want to change this to a deep copy. And we're going to just see the difference without me explaining anything of when I run this program now. So when I run this program, as you can see, it's now saying Jack and Bob. So this should confuse you a little bit if you're new to this topic. And I'm going to explain what is going on. And this is really the major difference between a shallow copy and a deep copy. So the difference is a shallow copy, if it's value type data, it's just going to copy the data over. That is it. If it's a reference type piece of data, it's going to just copy over the reference or the actual memory location, and that will be copied over so that they both point to the same location. A deep copy is not going to do that. A deep copy, yes, if it's value type data, it will just copy the value type data over. So that's the same as a shallow. Any type of value type data is the same for shallow copy and a deep copy. It will just copy the data over. The difference is when we look at a deep copy with reference type data. A deep copy does is it looks, okay, if I have a reference type piece of data, what it does is it creates a new memory location. It allocates new memory for this reference type data in the target, and then just copies the data over. So it's basically creating a new person description for P2, but then it's just taking the information from the source and just copying it over. So it's just copying that Bob and Henry over. But it's actually in a new memory location. So it's a new memory location, but it has the same data. And what that does is if I change that data, it's not going to affect the other one because they both have different locations of data. And I think the best way to understand this is by a little illustration. So I will I will make an excellent illustration in Paint for you guys to hopefully make this clear. So the first one I'm going to illustrate in Paint is the shallow copy. What is going on with that? So I'm not gonna draw this out while you're watching. I'm just gonna pause it and do it real fast, and we'll jump right back. Okay, so I didn't I didn't make the P2 yet. This is the basic setup. So we have P1, and this is performing a shallow copy. We have P1, which has an age of 15. It is a value type variable, so it's being stored essentially with it like this. That's a good way to think of it. Then we have a reference type variable. So this reference, the first part of it is being stored. You can think of this as the stack. It's being stored right here. And all a reference type variable is some kind of variable that's pointing to some other memory, some other information in memory. This is what a reference is. This is how references work. And if you want to learn more of this, look at my video on value types versus reference types. So this is a reference. It has this information, which has an address that just essentially points to this other memory. So description is a reference type that is being stored. It's a class. It's being stored somewhere else in memory, somewhere on the heap. And it's being stored over here, and this is holding the information Bob and Henry. So this is what's happening. So this is my P1. Now, when I create P2 and perform the copy, this is what happens. So let's go ahead and draw this. So our P2 is going to be down here. So we're doing the shallow copy with P2. Hold on. So this is P2 down here. So what happens with the shallow copy is the first thing is age is a value type variable. It just gets copied over like that. Now, if age is 15, it's sitting right there. That's it. But for description, so descriptions here, what's happening is a pointer, now they're just pointing to the same location. So this is what's happening. So this is what a shallow copy it does. It basically creates this new variable, copies over any of the it just copies over any of the value type data like the 15, and then the reference type data, it's pointing this into the same location because the memory location got copied into description. So now this is the picture we get. So now P2 and P1, their description data is pointing to the same description data. So if I change P2's name from Bob to something else, it's going to affect P1's because they both point to it. This is a shallow copy. So now let's take a look at a deep copy. So I'm going to go ahead and change this. 1 second. So I just crossed out the shallow copy word. So this is what's going to happen with a deep copy. So let's say now I'm performing a deep copy. So the same thing happens with age. Age is a value type variable, and the 15 just gets copied over like that. It's the same thing. But now this is the different part. So for description in a deep copy, instead of them pointing to the same, now we have description over here, and this is what's going to happen with this. Oops, hold on. Okay, so this is what's happening with the deep copy. So basically, with the deep copy, we now have two separate descriptions in memory. Somewhere they're completely different locations on the heap in memory. So even though with a deep copy, it's still a copy. So it's still copying the Bob and Henry to this Bob and Henry, to this description. But the difference is that these are completely different memory locations. You know, in the shallow copy, the Bob and Henry stay for P1 and P2 because they're pointing to the same Bob and Henry. This keeps the Bob and Henry in P1, P2, but they're pointing to different Bob and Henrys. They're pointing to different ones that just have the same name, ironically. You can think of it that way. So if P2 changes his Bob, P1 will not see it because look, it's different. If I cross this out, is P1's descriptions Bob crossed out? No, only P2's is crossed out. It's different. But in the last example with only one, if I crossed out Bob, then both of them did not see Bob anymore. So this is the difference. Then they now have their own memory, but they in the initial beginning they have the same data of Bob and Henry. So that is happening. That's what's going on with the deep copy. And the code for the deep copy is very simple. I'm just creating a new person. And instead of just performing the shallow copy, now we're just instantiating, using the new keyword, we're instantiating a new person, passing in the age of this age, so P1's age, P1's first name, P1's last name. This is being passed into person, so it's creating a new person. Then it goes to the constructor. This is the constructor calls. It calls this constructor, so that allocates new memory, and this is where we get all this new memory from. So by doing this, we're creating this new person description in memory that has the same data. That's it. And then we're just returning the reference that points to this. And in that reference, it's getting stored into P2. So that's all that's going on. The shallow copy they point to the same thing. With the deep copy, they point to different things, as you can see. But let me go ahead and comment this out. And with the deep copy, it's still initially, you can see that the Bob and Bob is there. It's copying the data over, but it just gets its own memory location. That's the difference between a shallow copy and a deep copy. So the last interesting thing I just want to look at is the difference of performing a shallow copy and then just using an assignment operator. Because I'm sure some of you are thinking, then the assignment operator in C# must also be performing a shallow copy. And this is what I'm going to leave you with. And this is pretty interesting. If I go person P1 equals that, and then person P2 equals P1, the interesting thing with this is that it's not actually performing a shallow copy. Rather it's just passing the memory location of P1 to P2. Essentially, it's creating an alias. So if I did console.writeLine P1 get hash code, and I did this for P2, you'll see that they have the same hash code, which is just showing that they are essentially aliases for each other. The P1 memory location is being passed to the P2 memory location. And that's different than performing the actual shallow copy. And look what happens with this. Person P1 shallow copy. Look at the difference here. We can see we get different hash codes to show that they aren't the same thing. P1 is not just passing the memory location to P2, rather that it is creating new stuff and then just passing the data in. It's creating a new P2 memory location. So this is actually performing a copy, whereas the assignment operator, just doing the standard assignment, is actually not performing a copy. There's no copying going on. This is actually performing the copy. Rather, the assignment is just making an alias. This is actually making a copy. But, you're going to find yourself in situations where the alias will be just fine. There's only certain locations where you'll actually want a physical copy. And before I end this, I just want to clear up one thing that I said with this illustration that I don't want people saying, "Oh no, you're wrong," which I feel like would happen. I was just trying to explain this to show a point. But technically, P1 and P2, they are reference types variables, so they're being instantiated. So age and description, those variables that are actually holding the data, I mentioned that they're being stored on the stack. And now that I'm thinking that is not completely accurate. It's not accurate. It would be a different story depending on different situations, but because I'm allocating them, the P1 variable itself, this guy and this guy, those are being stored on the stack, and age and description will also be stored on the heap. I actually go over this in the value type versus reference type video. But yes, age and description are being stored on the heap. I don't really want to go into it too technically in this video, but yeah, the actual description variable itself that's holding the memory location to this they're both being stored on the stack. I mean on the heap. Okay, that is it for this video. So yeah, so that's really what I wanted to cover. We were just looking at the shallow copy and the deep copy. So I hope this maybe clears up some stuff. So thanks for watching. Be sure to stay tuned for any upcoming videos. I'm not sure what any upcoming videos in this series. If you guys have any ideas about videos I can make in the Advanced C# series, by all means let me know. Like I said, a viewer just mentioned to do this, and I decided I should do it. But I don't have any more planned for Advanced C#. So if you have any ideas, let me know. I know someone mentioned like doing Link or something in Advanced C#, but I don't want to do Link in Advanced C# because Link is a really big topic, and whenever I decide to finally do Link, I want to make a whole series on it because it's going to be pretty long. But there are definitely going to be new things coming out. I want to make sure that I kind of catch up on all my series. I want to do more WCF. I need to finish up the C++ fundamentals. I need to finish up the data structures, C++. I need to catch those up because I've been slacking on those. But then after that, it's going to be open of what I should do next. Like Windows Phone development, iOS development using C# with Xamarin, maybe WPF. We could also get into Unity and look at building games with the Unity engine with C#. So it's all open right now, but yeah, there's definitely a lot of potential for this channel because we have so many things to make on. So I'm never going to stop making videos. There's always going to be stuff to make videos on. So thanks for watching, and yeah, be sure to check out any other videos.